an extension of the Tethys Sea, sir?
Mediterranean Sea is an extension of Tethys Sea. Yes, you can say. Mediterranean Sea is an extension of the Tethys Sea. And now where the Tethys Sea was located in the Asian part, now there is a formation of the Himalayan mountain ranges. So when I will be
Yes, sir.
discussing the geography of India, I will explain you that how the Himalayas have been formed by as per the plate tectonics theory. Because plate tectonics theory has explained how the fold mountain ranges in the Asia, that is the Himalayas, how the fold mountain ranges of the North America, that is the Rocky Mountains ranges, as well as the Andes mountain ranges of the South America have been formed. So it can be explained with the help of the plate tectonics theory. Right? So plate tectonics theory has explained all these, what you can say, the geographical phenomena, that how the fold mountain ranges have been formed, how the volcanic mountain ranges have been formed, and how what you can say the volcanic arcs and islands in the middle of the oceans have been formed. Fine. Okay.
Yes, sir. Thank
So
you.
is there any problem for others to join the class? Because I can see only 20 have been joined, because in the first session there were around 25 to 27 students have joined. Any problem while joining the in the session? Okay, so
No, sir.
No
no problem. Fine. Okay, so I will show you one video, which is a very short video, but it will help you in understanding what you can see in the difference between the continental drift theory and the plate tectonics theory. Fine. So just what I can say. Okay, can you all see the screen now? Is it visible to all of you?
Plates are moving away from one another. Let's take a closer look at what.
So is the video audible to all of you? Can you hear the voice of the video?
No, sir.
It's visible.
It is visible, but it is not audible, right? I'm just trying whether the video, if I share to you, whether you can hear the video or not. So I'll just trying now. Is it audible now?
From ever-changing weather patterns.
Yes, sir. It is audible.
Yes, sir.
Our
Fine.
planet is
Fine. So I will like take the full screen.
Sir, it is audible, but the volume is quite low, sir. Actually, very, very much low, sir.
Sure.
Earth is a remarkable piece of real estate, and a busy one at that. From ever-changing weather patterns to the hustle and bustle of city streets, our planet is in a constant state of motion. However, if we take a look just below the surface, we find that things are always moving below our feet as well. It's called plate tectonics, and it's how the continents were formed and reformed and reformed. But before we get to that, let's dive underground to learn what our planet looks like from the inside out. Our Earth is made up of layers, and there are two types of layers we need to learn about in order to understand plate tectonics: the compositional or chemical layers and the mechanical layers. We could spend an entire session on what makes both of these types of layers unique, but for this lesson, we're simply going to provide an overview. There are three primary compositional layers to the Earth's surface, and these are probably the ones you're most familiar with: the crust, the mantle, and the core. It's important to understand that the compositional layers refer to the materials or...
Okay, so what plate tectonics theory says that the whole earth is what you can say divided into three layers. The upper layer is called as crust, the middle layer is called as mantle, and the inner layer is called as core. So in this mantle, the matter which is there in the mantle is in a liquid format, that is in the molten format, and the crust is in solid. So the whole crust is what you can say broken into various plates, and this crust is moving over this molten mantle, right? So and again, if the convective currents are created here, like here the convective current is created, here the convective current is created, here the convective current is created, and when the convective currents are created, then when this material is moving in a circular fashion, the surface of the earth is also moving in a circular fashion. That is what it says.
However, if we take a look at how the inside of the Earth behaves, we can divide them even further into mechanical layers. Starting from the outside working in, the lithosphere is the outermost layer of the Earth, which contains the entire crust and the topmost layer of the mantle. The asthenosphere contains the same materials as the top layers of the mantle, but the pressure and the heat are increased. It's not exactly a liquid, but it does move like heated rock, so you could say it's somewhat fluid. The mesosphere is next. At this level, the pressure is really starting to build, which restricts the molecule's ability to move, thus making it very, very rigid. Past the mesosphere is the liquid outer core. Extremely high temperatures melt the metals contained in this layer into liquid form. Think flowing rivers of lava, and you'll have a pretty good idea of what the outer core is like. And finally, we reach the solid inner core.
So I'm going to discuss about the interior of the earth in detail. Don't worry about it, but you just have an idea that the earth is divided into various layers. I'm going to discuss in detail about the various layers of the surface of the earth, but you just need to know that the earth's interior is divided into various layers, and where the moment of the matter is what you can see in a different directions. That is what is explained here. Is the video audible to all of you? Can you all hear it?
Yes,
Yes,
sir.
sir.
Fine.
Core. Just like the liquid outer core, the inner core has extremely high temperatures and is composed of mostly metals, which might lead you to ask, why isn't it liquid as well? The answer is pressure. There's so much pressure at this depth that even though the temperatures are beyond the melting points of the metals contained in the inner core, the high pressure essentially squishes everything down into a solid. Now that we know a bit more about the composition of the Earth, let's move on to plate tectonics. Let's start with the history. In the early 1900s, a scientist named Alfred Wegener noticed that the coastlines of several continents looked like they fit together, similar to puzzle pieces. He believed that around 200 million years ago, all of the continents were joined together in one large supercontinent that he called Pangaea, which is Greek for all the Earth. Over the course of millions of years, Pangaea broke apart into the continents we know today, a process he called continental drift. Although his theories explain quite a bit about the origins of the Earth, scientists at the time weren't exactly impressed and initially dismissed his ideas. Fast forward to today, and Wegener's concepts are the basis of the modern-day plate tectonics theory. So what exactly is the plate tectonics theory? Well, it states that the Earth's outer mechanical layer, the lithosphere, is divided into large continent-sized plates that are constantly moving. How fast are they moving? Pretty slowly, actually, around 1 to 2 inches per year, which is why it was so hard for scientists 100 years ago to wrap their heads around the idea. So what changed their minds? Well, a few natural discoveries in the 20th century made Wegener's theories seem more plausible. For example, in the 1950s and 60s, scientists discovered heated magma rising up through cracks in the oceanic crust called dikes, which is how new rock or new land is created. This realization that our planet is always reforming and reshaping itself from beneath lent credibility to Wegener's theories. Point Wegener. Not long after, scientists started plotting the location of earthquakes and volcanoes around the world and observed that the location.
Okay, now here you can see that majority of the volcanisms or majority of the earthquakes are in this vertical on the plate boundaries, that on the boundary of the plates. So this has helped the theories of the plate tectonics, saying that this plate, all these volcanisms and all this what you can say the all these what you can say these earthquakes are taking place on the surface, or sorry, on the margin of plate boundaries, because they are moving away from each other or they are moving towards each other. Got it? So all the earthquakes or majority of the earthquakes and majority of the volcanoes in the world, they are located on the plate boundaries.
Followed a similar pattern to the outline of the plates Wegener proposed. And then there was the fossil evidence. Fossils of tropical animal and plant species have been found in Africa and other places on Earth that are less than tropical. One plausible explanation was that Africa was once part of a larger continent that was home to these tropical plants and animals. Remember Pangaea? So in light of all this evidence, the scientific community started thinking maybe this Wegener fellow was actually onto something, which led to the development of our modern-day plate tectonics theory.
So when the geographers were not agreement with whatever the Alfred Wegener was saying, they tried to find out the actual reason for the movement of the plates, the movement of what you can say the continents. Fine. And then when they were studying, then they have what you can say come across a theory, and that is what is called as plate tectonics theory. Now, what is plate tectonics theory? That is explained here.
So now that we know the history, let's dive a bit deeper into how it all works. According to the plate tectonics theory, these massive lithospheric plates are all moving in different ways, and how they interact with one another can have a huge impact on the Earth. Where these plates meet are called boundaries, and there are three kinds. Convergent boundaries occur when two plates are moving towards one another. Transform boundaries occur when two plates are sliding past one another, and divergent boundaries occur when two plates are moving away from one another. Let's take a closer look at what happens at each of these boundaries. As we said, convergent boundaries are when plates are moving towards one another. When the two plates collide, a couple of things can happen. One of the plates will dive under the other.
Now, depending upon whether the boundaries are moving towards each other or they are moving away from each other or they are being transferred, different types of landforms are formed. Now, which type of landforms can be formed at the convergent boundary? That is explained here.
Plate. It's usually the heavier, denser crust that dives under the lighter crust. This creates what is called a subduction zone. And the deeper under the Earth's surface that plate goes, the more pressure it creates. That pressure, coupled with a high heat, causes the crust to melt, forming magma. The magma presses up towards the surface, and voila, you've got a volcano. An example of this is the Ring of Fire, which is an active ring of volcanoes that encircles the Pacific Ocean. The other thing that can happen when two plates press into one another at a convergent boundary is the rock above the boundary will be lifted up or folded and form mountains. Ever hear of the Himalayas? That's an example of two tectonic plates colliding. And because the plates continue to move, the peaks in this mountain range continue to grow. For example, Mount Everest, which currently measures around 29,000 feet, grows around an inch every year. So as you could imagine, it takes thousands of years for these mountains to form. But although movement at convergent boundaries is usually gradual, as pressure underground builds, the impact above ground can be quick and violent. Fast movement or slipping of the land can result in earthquakes, either above ground or under the ocean. And convergent boundaries aren't the only type of boundary that can result in earthquakes. At transform boundaries, the Earth's plates are sliding past each other in opposite directions, which creates a crack or fault in the Earth's crust. As the plates try to move, they rub against one another, resulting in the building up of pressure. If the plates are stuck for a long period of time, the pressure will continue to build at the fault line until eventually it releases, resulting in an earthquake. The San Andreas Fault System is one of the largest transform boundaries in the world, which is why that area has more than its fair share of seismic activity. That just leaves divergent boundaries. Like we mentioned before, divergent boundaries occur when plates are moving away from one another. Either the space between the two plates widens and becomes a large crack or rift, such as the East African Great Rift Valley that runs from Lebanon to Mozambique, or if the space between the two plates is under the ocean, where the crust is thinner, magma oozes up from the Earth's mantle and fills the space. This is called seafloor spreading. The Mid-Atlantic Ridge is an example of where seafloor spreading has occurred. The crust under the ocean pulled apart, allowing magma to fill the space between, creating the tallest and longest mountain chain in the world. So in review, the plate tectonics theory is based on concepts first proposed by Alfred Wegener in the early 20th century. It states that the Earth's outer mechanical layer, the lithosphere, is divided into large continent-sized plates that are always moving, leading many scientists to believe the continents we know today were once part of a supercontinent called Pangaea. These plates move 1 to 2 inches per year. Where they meet is called boundaries, and there are 3 different types. Convergent boundaries, where plates collide, transform boundaries, where plates slide past one another, and divergent boundaries, where they move apart. Volcanoes and mountains form at convergent boundaries. Earthquakes and tsunamis can occur at both convergent and transform boundaries. Fissures and large cracks in the surface occur when two plates move apart at a divergent boundary. And seafloor spreading occurs at divergent boundaries located at the ocean floor. So that completes our lesson on plate tectonics. As always, feel free to use the scrubbing bar at the bottom to go back and revisit.
Okay. Okay, fine. So all of you got it. How the plate tectonics and what is the difference between the plate tectonic theory and the continental drift theory, right? So this is again a basic of that how the continents and how the oceans have been formed, and why all these continents and why all these what you can say the ocean have been are located on that particular area only. So that's what is explained by the plate tectonic theory and continental drift theory. Fine. So in tomorrow's class, I will be discussing with you that which type of landforms are formed on the surface of the earth, types of landforms and how they are formed on the surface of the earth, that I am going to discuss in the tomorrow's session. Fine. Any doubt for today's class, like for today's concept, Alfred Wegener's continental drift theory and plate tectonic theory? If you have any doubts, we can discuss, and then we will wind up. Yes, any doubts?
Sir,
Yes, Chandrasekhar.
sir, Alfred Wegener, he given some evidence, right, sir,
Right.
about
Right.
the continents movement,
Right.
right? So there are some other evidences. You, I think you not mention about that.
Yeah, that is not mentioned, but it is mentioned in the notes. You can go through the notes and you can, what you can say, go through it. But again, the evidences which have been
Okay.
given by the Alfred Wegener, they have been, what you can say, rejected by the scientists. But yes, there are some other evidences also which have been
Okay.
given by Alfred Wegener that have been mentioned in the notes. We can go through it. That's why I have shared you the
Okay.
PDF. So you read that PDF, and if you have any doubts about that PDF, you can ask.
Okay, sir. Thank you, sir.
Okay. Any other doubts? You are getting it, or is it becoming
Yes.
difficult? Because I
Yes,
have some
sir.
limitations, because online I can't teach. If I have a blackboard and what you can say the marker, then I would have done it in a very easier way to understand you. But since now we don't have any other option than going through this way of what you can say the learning. Fine.
Okay.
Yes, sir.
Check it. Chaliye. So if you have any doubts, you can ask me tomorrow. You go through it today, read both plate tectonics theory as well as the continental drift theory about the origin of the earth crust. If you have any doubts, you can ask me in tomorrow's session. Okay. Chalo, thank you so
Okay,
much. See you tomorrow
Thank you, sir.
again. Yeah.
sir. Thank you, sir.
Thank you, sir. Thank you.